will be discussing about runtime environment or memory organization or management in the compiler. So basically, if we talk about memory, we have a code area where code is kept. Then we have a global or static area. Location of static data can also be determined at compile time. We have some free space where we have a stack and a heap. Stack moves downward, heap moves upward. Stack is used for data allocation at runtime. And basically all the activation records are stored in the stack. Activation records are called whenever we give any procedure or function call. Heap is also a dynamic allocation area, and here data is allocated at runtime. For example, we have malloc area in C where whenever we give a call to malloc, we actually are giving the variables at the runtime. So this is how main memory is distributed. Now, if we talk about code area, in code area we have addresses in code area which are static. That means static means that there will be no change during execution time, and dynamic is that the execution will be determined at runtime. That means when the program is actually running. Addresses are known at compile time, and in data area, this is the addresses in data area are static for some data and dynamic for other. We have two type of basic dynamic data storage allocation methods. One is stack, last in first out, and another is heap for user allocated memory. There are three type of runtime environments. First is fully static. That means no change at the runtime. Second is stack based, which is partially static, partially dynamic. And third is heap or fully dynamic. So if we talk about static runtime environment, static both local and global variables are allocated once at the beginning and deallocated once the program terminates. So that means that particular location of the memory is fixed. Correspondingly, the addresses are also fixed. Since we have statically fixed the addresses, we cannot go in for any dynamic allocation. That means before the at the compilation phase itself, before running the program, all the addresses for all the variables are fixed. Since we are saying that there is no runtime allocation, so we cannot have a call to recursive procedures, because recursive procedure call means that within a procedure you are giving a call to another procedure. Procedure calls are allowed, but no recursion is allowed. One activation record for each procedure, and that also allocated statically. This was done in a programming language called Fortran 77. Then we come to static code and data. The code area of a program is fixed prior to execution. Thus, the address can be computed at compile time itself. Actually, the location of code is usually relative to some base address or base register. Say, for example, I am having array allocated with the initial address as 102 in one computer. Now, if I move to some another location, that 102 will be where the array was supposed to start will be treated as base with the index 0. If I take it to 104 instead of 102, it will be 102 relative to 104. That means 0 position will be fixed as it is, and we will go in for relative addressing. The address for data is in general not assigned fixed location at compile time. Static data does memory and is known at compile time. Then this is an example in which we are considering a main program with the name max, which is allocated global area. Then we have a call to an activation record where we have tab 1 to 10 being declared. Then we have a call to qmin, which is a subroutine or a procedure, which you can say with three variables, a, size, and mean. Now see, when we were declaring these parameters, here qmin is tab, so tab will be matched with a, size will be mapped with 3, and mean will be mapped with temp. This temp means temporary variable. So if or a temperature or whatever the user has defined correspondingly. So whenever there is a call from main to qmin, a new activation record is generated first activation record was for main, next activation record is for qmin, and there is a variable mapping or parameter mapping between the actual and formal parameters. So this is how activation records are generated in static environment, and we fix them beforehand. When we talk about dynamic data allocation, memory for dynamic data is typically organized into two major areas. First is stack, which is used for local variables, parameter variables, return addresses and return values, and second is heap, which is used for dynamically allocated variables. Now we come to stack-based runtime environment. In static storage, storage is organized as a stack. Activation record is pushed onto the stack when activation begins and is popped when the activation ends. Activation record, what all the contents activation record contains? It contains the locals so that they are bound to fresh storage in each activation record. The value of locals is deleted when the activation record ends. And we are pretty well aware of that in stack, we have LIFO, that is last in, first out strategy, which is being followed. And this allocation supports recursion. If we talk about heap-based runtime environment, it is the most flexibly allocated scheme for the memory management among all three. Allocation and deallocation can be done at any time and at any place depending upon user's requirement. It is used to allocate memory to variables dynamically, and when the variables are no more used, the area is claimed back, and it supports recursion. Now, what are procedures and what is a procedure call? Execution of a procedure starts at the beginning of procedure body. When the procedure is complete, it returns the control to the point immediately after the place where the procedure was called. And this process of activation, execution, all the calling of the procedure, then execution of the procedure, this is called activation. What is the lifetime of an activation? Sequence of steps between the first and last step in execution of the program. If A and B are procedure activations, then their lifetime are either non-overlapping or nested. If a procedure is recursive, that means call to a procedure within a procedure, new activation record begins before an earlier activation of same procedure as, and this is what we call as recursion. Fact of 5, if we call it by recursion, fact of 5 is fact of 4 into fact of 3 into fact of 2 into fact of 1. So we will keep on taking the values of all, and in the end we will multiply them. What is an activation tree? We can use a tree to show the way control enters and leave activation. So in activation tree, we have a node where each node represents an activation. We have a root which represents the activation of main program. Node A is a parent of node B if and only if the control flows from A to B. Node A is left to node B if and only if lifetime of A occurs before the lifetime of B. Say for example, in this case, we have a main program, followed by that we have procedure S, then we have within procedure P, we have a call to procedure Q, within procedure Q, we have a call to procedure S. So how we will represent it? Here is the main with the entry and exit point. Within P, we have a call to Q and S, and we have a separate call to S also. So this is a nested structure of activation. Again, if I represent this thing in the form of a tree, it is that main is giving a call to P, P is further giving a call to Q and S, and main is also independently giving a call to S. Then we talk about control stack. The flow of control in a program corresponds to depth first traversal of activation, starts at root, visits a node before its children, and recursively visits children at each node in left to right order. So we have a stack which we also call as a control stack, which can be used to keep the track of live procedure activations. What we do is that we initiate an activation record which is pushed onto the control stack as the activation begins, and this activation record is popped when the activation ends. When the node N is at top of control stack, the stack contains node along with path from end to root. I'll show you all these things in the coming slides. The same variable name can be used in different parts of the program. So we have two types of scope. One is local and another is non-local. Local means limited to the same procedure, and non-local means that it is called from different procedure. The third option is that we have global also, in which it is defined for all the procedures and it can be called from any of the procedures. So here, if we talk about procedure P, which has a variable B, again, we are giving a call. We are defining a variable A of type integer. Within this, we are giving a call to B. So this here, in this case, B is non-local and A is local because we have defined A here only. Then next comes the activation record, the most important thing which we need to consider in compilers, how these activation records are generated, what are the role of activation record. Information needed by single execution of a procedure is managed using a contiguous block of storage called activation record. An activation record is allocated when a procedure is entered and it is deallocated when the procedure exits. Size of each field can be determined at compile time, except that if the procedure has local variable and its size depend on parameter, it is determined at runtime. These all the options which are given in the activation record need to be thoroughly understood and learned. What are the parameters of activation record? First is the return value. Return value of a called procedure is returned in this field of the calling procedure. In practice, we may use machine registers for return value. That means, say for example, I was at my program counter PC was at 0.1024. At 1025, there is a call to a procedure. So the return value 1025 is stored, the value where the PC will start off once the procedure has been called and the value has been taken. So this is the return value 1025 will be placed over here. Next come actual parameters. There are two types of parameters. One are formal parameters and another are actual parameters. Field for actual parameter is used for calling procedure to supply parameters to the called procedure. Then we have optional control link. The optional control link points to activation record of the caller from where the call was given to the callee. Then we have optional access link. Optional access link is used to refer to non-local data held in other activation records. Why this is optional? There is a pretty well chance that you might not require any access to non-local data. Then we have saved machine status. The field for saved machine status holds information about state of machine before the procedure is called. Local data, which is required for the procedure itself. Fields of local data hold data for local local to an execution, and temporaries, which are used to store the data. Say for example, I have a expression of the type x is equal to a plus b into c. So b into c will be calculated, it will be stored in a temporary and then it will be added with a. So this is the role of temporaries. So these all 7 important parameters form the actual activation record call. Now say for example, I have the code for a program in which we have a main. From main we are giving a call to procedure P, then we are giving a call to procedure Q. Now how these values will be allocated to the variables? Initially we are giving a call from P to Q. We are initializing this with 1. So we will have A is 1, Q1. Then we are augmenting this value. Initially A is 1, Q is 1. We are augmenting this value by 1. So we have A is 2, Q2, A3 giving a call to Q procedure again. Now this is how caller and callee's activation records are generated. There's a caller which has all these control stack parameters. Then we have a callee. Caller is the one who is giving a call. Callee is the one who is called by the caller. Variable length data is allocated after temporaries and their link, and there is a link from local data to array. Say for example, we have some variable length data. In variable length data, the size of the user input can vary. How do we access the non-local parameters or variables? Now in this, say for example, we are giving a call. I told you that access link is the point which will actually link one procedure to another procedure if there is a call to some non-local variable. Then access to non-local names can also be there, not only to the variables but also to the names. Scope rules of a language determine the treatment of reference to non-local names. We have lexical scope, that means we can call them only statically or we can call them dynamically. If it is static, then it determines the declaration that applies to a name by examining the program text alone at compile time, whereas in static scope, it will be at runtime. Accessing variables in local procedures, we have accessing two methods. First is access chaining, which follows access links from one activation record to another activation record. And second method is using of displays. We will be considering both these methods in the coming slides. This is if we are using access links, we have nesting. In this case, what is supposed to be done is that activation record level 1, activation record level 2, you can see here it is for a procedure called cal, here it is a procedure average, and then for sum. Nesting levels are indicating the depth of the procedure in the program. Level 0 is the outermost level, needs to be stored in symbol table. To find the activation record for nth nesting level, from the activation record in ith nesting level, we need to follow the access link n-1 times. This is how activation will take place. Level 1, level 2, level 3, we need to call each and every level in order to identify nth level. This is how activation access links are actually chained together. We have access chaining. On the other hand, the second method which can be used is displays. In display, what we are considering, we are storing the access links in an array. We are having a display array where we are storing the activation links of all the records which are active at a particular point. The activation record of procedure in the ith nesting level is stored in display I, so we can directly move to that particular activation record. So if we talk about access to non-local variables in displays, we can always store that value also corresponding to the display array number. That is the index of display array. Then we come to the last topic, that is parameter passing schemes, which three majorly used, in fact, two majorly used are pass by value, pass by reference, and we can always have pass by value result. In pass by value, value parameters are not changed during the execution. Only value is sent into the procedures and are used locally. When the control is returned from callee, value of the parameter is not passed back to the caller. In call by reference is passed, value is not called, reference is passed. Reference to a variable is passed to the callee. Callee uses the reference to refer the variable. Indirect addressing is needed to refer to the parameters. The variable in the caller and reference memory in the callee share the same memory location. That means the point where the actual data was stored, that is being referred, and the point where the procedure is giving a call to that particular data, there will be a pointer indicating to the same value. Variables in the caller and reference in are share the same memory location. Value of the variable in the caller is also changed when the reference in the callee is changed. Last comes pass by value result. In this case, value of parameter is copied into the callee when the callee is entered. New memory location is provided for the parameters in the callee's activation record. And no indirect address is required as in the case of call by reference. When the control is returned, the value is also copied back. Next, we have examples of activation record generation and termination. I have added few slides. Say for example, I have a program for GCD, that is greatest common divisor. Now how it will work, initially I am giving the value of X as 15 and Y as 10. This is stored in the global area, static area. There's a call to activation record. Main, we are giving a call to main, block pointer, return value and address. Now we change the value Again, we are giving a call. Here U is 10, V is 5. Second call is given and then a third call is given. And we are generating the activation stack corresponding to every call to the procedure. And once that has been retrieved, we will free that particular activation record and value will be sent to the printf statement. Then we have one more example. We are giving a call. We have two pointers. One is block pointer and another is stack pointer. Initially, the user gave the values x is equal to 2 and f is equal to x is equal to 1, which is initialized. Now, value of m is 2. Now, value of m is 2, y is 1. We are giving a call. N is 10. A call is given to f. Then again a call is given to G. Once the value is returned, we will move back corresponding to all the activations records which were created. Memory will be deallocated and we will move back to the main program. So that's it. So with this, we complete this particular topic of runtime environment or memory allocation and compiler construction. Basic focus in this has been that how procedure call is given and how they are actually stored in the memory.